This week we are getting into other natural hazards, sort of continuing with what we learned last week, those specifically associated with earthquakes. Now expanding that to what is applicable to us directly as Michiganders and what some other places in the US and other places in the world may experience. For part 2 of Lecture 10, we'll completely shift gears and talk about some really fun stuff with Michigan geology. Firstly, we need to establish what exactly a natural hazard is. A hazard, just in general, is any kind of event that adversely affects human life, property, or activity. A natural hazard is anything dictated by nature. Notably, a natural event is only ever a natural hazard if it occurs at a certain level in an inhabited place. Natural disaster is like a step up from a natural hazard. It's an amplification of a natural hazard. This has to meet certain criteria for destruction and disruption of a functioning community. In order to be classified as a natural disaster, there has to be a widespread human, material, economic, or environmental loss associated with that natural event. Now, one caveat with that definition is that effect, that widespread human, material, or economic environmental loss, is dependent upon the capacity of the affected population. And that capacity is the accumulated resources of whatever community or society is being affected. As we saw in earthquake hazards, there are a number of things that we can do to prepare for seismic damage. Now, depending on the resources available to that community, they may or may not have the ability to put those kinds of structures in place. So a society with those structures would then have lesser destruction, less environmental, economic, and material loss than the community that was not prepared, did not have those resources. So the disaster standard is dependent on the capacity of that community. There are 5 categories of natural disasters, those being biological, geophysical, hydrological, meteorological, and climatological. You guys are unfortunately experiencing a biological natural disaster at this point in time. The first example there is epidemic. Forget that. We're straight at pandemic at this point. And a lot of these biological hazards have to do with viral infections or infections in general, disease. But one thing that we may overlook is that an example being an animal stampede. You guys have probably seen that scene in The Lion King, the one that kills Mufasa. Yeah, that's technically a natural hazard. That natural hazard for that example being specifically to the lion population. If Mufasa wasn't there, he wouldn't have died, which means that it wouldn't be a natural hazard, just be a natural event. So it's sort of like if a tree falls in the forest and no one's around to hear it, did it really fall sort of thing. Geophysical is the category that you guys are most familiar with at this point. We've talked a lot about earthquakes, some about volcanoes, rock falls, landslides have come up for us. Avalanches we have not talked about, but you guys know a good deal of subsidence as well. The 3 categories here on the far right, hydrological, meteorological, and climatological, are all types of hazards that we here in Michigan face fairly often and are fairly prepared for. Hydrological natural hazards really come down to flooding and things that are affected by flooding. If you take a look at that mass movement with wet in parentheses there, the list for that matches that of the geophysical list for mass movement with dry in parentheses. And so these are the types of things that can become much more damaging when lubricated with water. And mainly that's because things are moving a lot faster. Meteorological really just refers to any kind of storm, tropical cyclone, hurricane, tornado, anything like that. Climatological are quite a wide variety of effects related to climate change. So this can be a heat wave or a cold wave, any kind of extreme weather conditions in one side of the spectrum, very cold, or the other side of the spectrum, very hot. Anything produced by those kinds of conditions, such as drought or wildfire, forest fires and land fires included in that as well. So this is from our state government's website. these, according to our government, are all of the natural hazards that Michigan is prone to experiencing. Now, obviously, these aren't in any kind of particular prioritization order. Otherwise, winter weather would certainly come before earthquakes. But one of the main things that we have to deal with are obviously winter weather and flood, the occasional extreme heat, obviously disease outbreaks right now. But I am going to be using this website here, floodfactor.com, to illustrate for you guys what kind of natural hazards and specifically flood risks are associated with any given location in Michigan. Now, this is built primarily for homeowners, but there's a lot of other good information on here. So I'm going to use Western Michigan University for the example here, and I'm doing that because some years ago their campus flooded after quite a bit of rainfall, and that was around their homecoming weekend. They actually ended up having to cancel homecoming that year. And unsurprisingly, Western Michigan University falls in the major risk category for flooding over the next 30 years. So this is all a statistical risk analysis. This is the same data set and risk analysis approach that many insurance companies use, and it's all based on timelines, specifically here 30 years. You can notice also that over here it says that Western Michigan University has a major risk of flooding over the next 30 years, but this in comparison to other neighborhoods in the area, it's 91% greater overall flood risk. And this is, by this breakdown here, is mostly an infrastructure issue. All of these figures or percentages are surrounding this idea of the buildings being severely affected. And this is a function of the depth of the water. So if the water meets the threshold of a building, we're in severely affected territory. Now, if it doesn't enter the threshold, that doesn't mean that there isn't any effect, because anything that's lower lying, such as garages or basements, can still incur quite a bit of damage. If we go over here to the Flood Risk Explorer, we can see an aerial mapped projection of this risk surrounding the idea of being severely affected. With this, we can clearly see the bounds of our high-risk areas in dark purple, which are going to be areas prone to 3+ feet of flooding, and then those which aren't expected to have any flooding, with no coloration and very little or mild flooding, less than a foot, with the light blue coloration. And you can see that these darker areas, the dark purple, the more flooding, occurs at natural topographic lows. So we can see it following natural water bodies and moving into detention pond type areas. It should come as no surprise that this is where the most flooding occurs, since water flows from high to low. It's going to move towards these water bodies anyways. Most areas in Kalamazoo, or Michigan in general, don't have major risk of flooding. This is kind of a special case, but you can see just how much that risk varies in short lateral distances. If I live in this house right here, I'm going to be much more concerned than if I live in one of these houses out here. And if we zoom out, we can see a much greater distribution around the Kalamazoo area. Most all of the greater Kalamazoo area is in pretty decent shape in terms of flooding risk. There's a whole lot of clear, a little bit of blue, and not that much dark purple here. However, many places around the US are not so fortunate in these terms. If I were to look up my home city of League City, Texas, this is just south of Houston, we're going to see some very different results. With an initial look at this, you may be thinking, well, severe's not good, but that wasn't a huge jump from what we looked at Western. Mind you, Western is a single property, or a small number of properties. Here was 8 properties in Western Michigan University, whereas this for an entire city is closer to 18,000, well, 19,000, and represents nearly half of all properties in the city. If we look at the Flood Risk Explorer for this one, the general area looks an awful lot different than that of Westerns. There's an awful lot more area covered here in the no good, bad, purple risk color. And this risk distribution really shouldn't come as too much of a surprise either. We can see here that yes, this also follows those natural drainage paths, these rivers in here, but it's also all of this coastal area because this is right on the Gulf of Mexico. So why would anybody bother building communities in this area if they know that there's a ton of risk associated with living here with flooding? Well, number one, there's some infrastructure in place that can help prevent flooding itself, but also help prevent damage resulting from flooding. So that sort of provides a loophole around Mother Nature's contract there. But the other part is that it didn't always used to be this way. Houston is currently under sea level. It used to not be that way just some decades ago. And that change going from above to below sea level and therefore more at risk for flooding is in part because of groundwater withdrawal, and the other part is due to climate change. With the groundwater withdrawal, over the last several decades, the population of Houston and all of the surrounding cities have been drawing from this one major aquifer, so much so that they've sucked it out, and that land has subsided because once we take the water out, we can't put it back in. That pore space, that space that the water once occupied, is now empty because the water got sucked out and then the rocks closed up that space because there's no water pushing that space open anymore. Once that level falls, we can't push it back up. So the land itself has actually dropped. The other half of the equation is that the sea level has risen. There's a nice feature on here where we can come over to the environmental changes section and see just how much flooding risk has changed with changes in precipitation and sea level rise and sea surface temperatures just this year, but also in the last 15 years and the last 30 years. So let's start with sea surface temperatures over the last 30 years. Now this is showing how much temperatures of the surrounding oceans have increased over the last 30 years. So given all of these points here, we're looking at roughly 2.7 average for our surrounding oceans. 2.7 degrees Fahrenheit may not seem like a whole lot of change, but the warmer water is, the more it expands. So that is a very minute part of it. But the large part of sea level rise is the melting of the glaciers. So with increasing ocean temperatures, the glaciers will continue to melt. And we have an entire unit ahead of us, an entire week ahead of us on climate change, but this is just a brief introduction to it and how it can affect individuals. Again, this is all something that gets taken into account by insurance companies when they are issuing your monthly payment for flood insurance, at least in these types of areas where people get flood insurance. Here in Michigan, we don't necessarily need it in most places. Western hopefully has their own flood insurance. I'm sure they learned that lesson a few years ago if they hadn't already. But we can look at the same timeline, the last 30 years of sea level change around the entire US, and the longer the arrow, the more proportionally sea level change there's been. And you can see here the scale is about positive 5 inches for this portion here. So with sea level rising, it's not a shock that all of these coastal areas are the areas in which we're seeing sea level rise take place. Inland's going to be fine for quite a while, but we're seeing the greatest increase in sea level around Houston, Louisiana, Alabama, these parts of the world, or the US. The other component that's considered here is precipitation change over, X period of time for whatever equation the insurers are using. Again, we'll get deeper into this with the climate change lecture, but One of the general trends that we see with climate change is that there are higher highs and lower lows. So while the overall trend globally is an increase in temperature, there is a geographic distribution where areas that experience cold colds are experiencing colder colds, and those experiencing hotter weather are experiencing even hotter weather. With this, that means more extreme weather events. So more extreme hurricanes, more extreme winter storms, more extreme drought, so on and so forth. This part of the equation is actually somewhat fortunate for Houston, or more specifically League City, Texas, because while they're more at risk in general for flooding compared to the rest of the U.S. because of subsidence and sea level rise, they're in a little dry pocket for part of the U.S. that's actually experiencing less extreme rain events. That's because we have more extreme rain events happening towards the coast, both the west side and the east side, than we've seen in the last few decades. And that's partially because of the warming of the oceans and the changing of the currents and the redirecting of tropical storms and hurricanes. Again, we'll get more into detail with that, but this is just the numbers and what we're looking at risk-wise for natural hazards. And this, of course, can affect you when it's happening, but also when it's not happening, in the way that that risk is assessed and you are charged to protect yourself from that risk. As we've established here in Michigan, we have a pretty low risk of flooding, but we also have a pretty low risk of just about every other natural disaster. As of 2021, Michigan was ranked the safest state to live in the U.S. in terms of natural hazards. We hardly get any flooding. Our earthquakes are a mild disturbance at best, and the hurricanes can't touch us. So we're doing pretty well in that regard. However, of course, we still deal with a good portion of winter storm events. While having to pick up our yard furniture might be the consequence for us for being ill-prepared for a natural hazard or a natural disaster event, that is not the case for the majority of the world. That majority being about 2/3 of the world's total population. Mind you, these are natural disasters, so that means specifically there's a great loss in environment, life, and money as well. We've seen over the last 20 years about $2 trillion in damage, which just so happens to exceed the world's annual aid budget by about 5 years worth of monetary supplement. This figure displays the number of catastrophic natural events from 1980 to 2012 by category, those same categories that we looked at earlier of all of our natural hazards. Looking at those individual components, you can see the geophysical events. While there's a little bit of up and down, it's pretty well a flat line, very little change over those decades. However, the general trend of this graph, while yes, there are up and downs, it's generally upward with a fairly steep slope, which means that everything else on here is increasing in number. Storms, floods, droughts, forest fires, so on. But is this all because of climate change? Well, mostly, but also we have increasing population over these years, which means that we have more vulnerable people, and we have greatest population growth in areas that have the most vulnerable communities. The other component is better reporting / monitoring, better classification of these catastrophes, but that's a very small influence relative to the other two. Looking at that same data set here, just distributed geographically, we can clearly see what categories of natural hazards or natural catastrophes affect what areas. So here in the US, for the most part, we're dealing with those green circles, so that would be the meteorological events or storms. Also climatological events, extreme temperature, drought, and wildfire, with a few geophysical events out west, and then hydrological events, flooding, mass movement, quite a bit out east. But the size of all of these circles also correspond to the magnitude or number of occurrences. So the larger the circle, the more occurrences in that particular area. So by far, our overwhelming problem here in the US in terms of natural catastrophes are meteorological or storm events. Some people may ask, well, if there's so much risk with living in certain areas of the world, why would we bother living there anyways? Well, as we saw with the case of Houston earlier, it can be that the risk has changed over time, which is true for most all categories of natural hazards all the way around the globe. But also that it's not really always that easy to just get up and move, especially if you're trying to move between countries. But it's more than that. With a lot of these places, with all of these different types of risks, as you saw, most of the US was covered in different types of risks. It comes down to, one, people being attracted to the type of climate there. So warm, hot, and wet really brings a lot of people's attention in. Also living near the ocean, a lot of people like. Also with this kind of climate comes some economic opportunities with farming. And while that's not so popular now, it certainly was while the nation was being established, and that has a lot of influences to the infrastructure or cities that are built. And once families are in a city for generations upon generations, it's less and less likely that they'll start moving away from that area because that's home. Not everybody has anywhere else to go, so sometimes it's just due to a lack of alternatives. And then the last part is just sheer ignorance or not having the background knowledge or ever being taught that they're really at risk. Somebody can live in an area with regular hurricanes all the time and just that being second nature to them, that's just what it is, that's where they live. They don't understand that over the next several decades it's expected to get a lot worse and that their house will likely be under 5 feet of water over the next 50 to 100 years. And while that might not matter so much to the parents of that family per se, if they want their children to inherit that home, they might need to reconsider some things. Let's revisit that idea of capacity from earlier. The risk of disaster is completely and wholly dependent on both the natural hazard itself, so how frequent are these hazards occurring, what's the probability of it happening in the future, how fast does it come on, what is the magnitude of that event, how long does it last, how far does it go, so on and so forth. And also the vulnerability of the system, the strength of the infrastructure, and the overall resources of the community. How prepared is a community to mitigate the effect of the hazard or event itself, and how prepared are they to respond to the after effect? Most of these events, natural events, are relatively uncontrollable. However, the more prepared you are for any situation, the more in control of that situation you can be. But that, of course, is also a function of what resources you have available to you. So perhaps you are ready to study for several hours, you have all of your notes together, but you also have to work 40 hours a week, so you don't have the time resource available to you. You have the notes, you have the motivation, but you don't have the time, which means that now you're ill-prepared for, say, the test, and then it becomes a question of them responding to the aftermath of that, trying to get your grade up after a poor test, just as an example. You guys have probably heard in the news or seen online somewhere where following a natural catastrophe or disaster, they say something along the lines of caused X dollar, thousands, hundreds of thousands, even millions of dollars in damage. And that's because that economic loss is one of the few quantitative or number ways for us to define something qualitative or visual damage. And mind you, in any case, this is of course going to be dependent on how prepared a community was for such an event. So the more prepared they are, the least cost they will incur. Since 1965, most all of the world's most costly natural disasters have been either earthquakes or hurricanes or floods. Weighing in at number 3, taking home the bronze, is Hurricane Katrina. That happened in 2005, so most of you probably remember seeing some footage of that in the news, or maybe you even lived somewhere around Louisiana. I lived in Houston at the time, and there was certainly some damage stretching over that way too. And this event, of course, destroyed Louisiana and destroyed New Orleans, but it affected the nation on whole. And that comes down to a money conversation a lot of times, specifically in politics. And that's where the decisions to become more prepared for such an event happen. And that all comes down to assessing risk. And, of course, making a decision regarding that assessed risk, whether to ignore it or do something about it. And that last figure was ranked in order of economic cost. So if we take the same data for catastrophic events and their costs and then arrange it in order of time from 1970 to 2010, we see an overall trend in the increase of economic losses due to catastrophic natural events. This is basically the same chart that we looked at earlier with all of the categories of hazards, with, of course, geophysical not changing very much, but with dollar signs on it. And while both trends are increasing, we as a society have the potential to have more control over this one than the latter. While we can improve the trend for both of them, and improvement being in terms of the longevity of the human race, this is more of an immediate thing that we can do by continuing to build infrastructure, and then on the other side to make improvements with our impact on climate change. So while a lot of these topics can bring about some feelings of impending doom, the good news is that we do have some control over the situation, or the potential for control, and it's really important to talk about, because the more we talk about it, the greater the potential for control over the situation becomes. So to dramatically shift to a much more positive note, we will pick back up with Lecture 10 in Part 2 on Michigan geology.